Okay, but I'll start with modern human behaviour. So many of you will be familiar with Stanley Kubrick's 2001 Space Odyssey, where at the beginning of this, this film, we're treated to a scene which we are told is the dawn of man, this kind of point at which we become special in some way, you know, smart, or what we are, what we see ourselves as being different from other animals. And it turns out, at least in this story, that what's involved is our more hairy ancestors wandering around, somewhere presumably in Africa, and then a black monolith arrives and makes some strange noises, and somehow instills in our ancestors the ability to think in a way that we think today, and to do especially things like make tools. And of course, the first thing that we do with the tools that we make, or at least in this film it may even be true, is that we batter each other over the heads with them and use them to build up our power structures. And then we're told, at least in the film, that it's a relatively small step from using bones as tools to spaceships and space travel and all of the amazing technologies that we have today. And we're kind of left with this sense, really, that there's some kind of switch. There's some switch has been flicked in our head that has turned us from this, what's basically a monkey, to the human beings that we are today. Well, obviously that's fiction. Obviously it wasn't the black monolith from Jupiter or Saturn or wherever it was from. But it is absolutely true that there were stages in our evolution when something special happened. So we call this, generally in archaeology, it's called the origins of modern human behaviour. Okay, so this particular package of behaviours, of technologies and skills, in Europe and in Western Eurasia, archaeologists tend to call it the Upper Paleolithic transition, and purely for historical reasons. In Africa it's called the Late Stone Age. But basically they're talking about the same thing. So at this stage we suddenly see the appearance of stone tools that are very fine and made in using much more complex techniques.
I'm going to stop you just there, just for the fun of it. Can we do a quick zoom in on timescales?
Yeah,
we may need some help. Are you going to?
We're
going to the age of the universe?
Don't worry, we'll come to the timescales.
Are you sure?
Yeah,
numbers?
Yeah.
You sit down again then.
No, sit down. Sit down.
All right. I just got worried about how recent all this stuff was.
I will come to the timescales. I just want to, but what I really want to get, the point I want to get across here is that this whole package of behaviours seems to appear in certain places around the world at certain times. It's not like a gradual process. It does seem almost like a switch has been flicked somewhere in our heads or something like that. So we see the first use of antler and bone to make tools. We see the first evidence of making tools that can process food, like grinding and pounding instruments. We see the first evidence of people moving the raw materials they used to make these tools over large distances. All those things are really kind of a bit boring, really. Another couple of things that come with this is a package. The first is bling. So people start using body decoration in a really clear-cut way, both in the form of ochre to actually colour their skin, but also threading shells, threading ostrich egg and so on, shell pieces, in order to make these necklaces and other body decoration. And the other thing that is most dramatic is it's associated with the appearance of art and symbolism. And this is an example of a little bit later. So this first started in Europe about 45,000 years ago. This is a little bit later, but I think it's a particularly astonishing example. I mean, this is still over 30,000 years old. And it's not hard to look at this stuff and to convince yourselves that the mind of the person that made this stuff thinks ostensibly the same way as we do. Certainly more like us than they would like a monkey. And there's plenty of other stuff, including pornography and all the other things that you might associate with being able to make representations of things, especially these Venus figurines, which are found over a very wide area of Europe and Western Asia. Right, so now let's put this in context in terms of time. Well, we first started making stone tools around 2.6 million years ago. Actually, that date is about to be pushed back to about 3 million years ago. But that's where we first started. But without wanting to be disrespectful to our ancestors, those tools were rubbish. They were essentially just, large pebbles that had a slight shaping on one side, basically to break open bones. And they made this rubbish for about a million years, and we call that Olduvai stone tools. And there really isn't much to it. It doesn't change over that million or so years. Then we start making something called Acheulean tools. So you can see up here, they're much more shaped. They often got this teardrop shape, and then much more skill goes into them. And also another feature that's really distinct about them, and it seems fairly universal, is they're almost always symmetrical. And there's a real symmetrical element to the way they're made. But that stays just the same for about 1.5, 1.6 million years. You really don't see a lot of variation in them. And then we get a little blip between around 250,000 years ago and maybe 100,000 years ago, which we call the Middle Stone Age. And there are some experiments going on there. There are some slightly more sophisticated tools and so on. But basically, it's not really sophisticated. It's just a little bit of an improvement on what we call these Acheulean. Then, depending on where you are in the world, we see this explosion. So on here, let's say we'll talk about Europe, it's about 45,000 years ago. We see this explosion of technology. We see the first art, the first body decoration, we see the first use of antler, we see first musical instruments, we see the first sophisticated hunting tools like spear throwers, bows and arrows, and so on and so on and so on. So there is this absolute explosion in technology and modern behaviour. Okay, so who's doing this stuff? Well, we know that there are at least 5, I hate the word species because I think it's a bit weird because we know that they interbred, so they're not really proper species. But anyway, let's just call them species-ish. There are at least 5 species-ish of humans around at the time. There were probably more. In fact, from the DNA data that's coming out today, it's looking increasingly like we were living in a kind of Lord of the Rings type world, even as recently as 50 or 100,000 years ago. But certainly there was us. Certainly there were these strange creatures that have been discovered in Siberia called Denisovans. Certainly there were Neanderthals. Certainly there were these little hobbit things, the forensics people with tiny little brains that lived in the Flores Islands. And also in East Asia we had Homo erectus, who had slightly smaller brains than us. So which ones of those were doing this modern behaviour? Well, maybe the Neanderthals a little bit. Maybe they were just copying us because we overlapped with them. Maybe the Denisovans, we just don't know. Us, yes. The rest of them, definitely not. They were definitely too thick to do this kind of thing. There's just no way. But the really weird thing is when it appears. Because, as I said, all this behaviour seems to appear as a package. It's not like you get a bit of art but you don't get anything else, or you get a bit of, hunting instruments but you don't get anything else. It all seems to come generally as a package in these different places. And amazingly, it arrives at different places at different times, and the time when it arrives is not the same time as when our species arrives. Okay? So we're all what we call anatomically modern humans, Homo sapiens, but our species gets to different places and they don't always behave in a modern way when they get there. They do in Europe. So in Europe, arrive about 45,000 years ago, start doing it. Southern Asia arrive maybe older than 50,000 years, maybe it's even 70,000 years. That's still a bit uncertain, but you don't get this behaviour until more recently than 30,000 years ago. North Africa, Northeast Asia, they arrived 50,000 years ago, they don't do it until 22 or later. Australia, they arrive about 50,000 years ago, they don't do it until 20 or maybe even 10,000 years ago. And Africa's really weird, because of course Africa's home. This is where our species comes from. But what we see is that actually appears in this kind of fluorescence in southern Africa about 100,000 years ago. They get lots of this really cool behaviour, cool sort of stone tools, cool bling and so on. and also the first ever evidence of symbolic behaviour. This hatched piece of ochre is not particularly impressive, but it's the oldest piece of evidence of symbolic behaviour in humans that we have, and that's dating to around 80,000 years. So we get this explosion in Africa, but then it disappears. And it doesn't come back till around 30 or 40,000 years ago. So that's a bit weird. So we know that our species is there, but they're not always behaving in a modern way. So it's almost like there's a decoupling of being human and behaving in a human way, which seems quite odd. So this has led to a number of questions, and this has been a very, very enduring problem in archaeology and also in human evolution, is understanding this kind of decoupling of behaviour and us actually being there. So some people have suggested that the appearance of modern behaviour indicates some fundamental switch in the brain, some fundamental increase in our intelligence, in our cognitive capacity, in our ability to actually understand and learn. Others have argued that we had the intelligence to behave in this modern way before we did it. Now, that would help in explaining why this modern behaviour appears and then disappears and then comes back. But if that's true, then that must mean that we didn't evolve our smart brains to do the smart things we do with them. So we must have evolved them for something else. Because one thing's for sure is evolution has absolutely no foresight. It has no idea where it's going. It only has any idea where it is now. So it's quite a weird thought. Well, is there a correlation with brain size? Does that help us? Well, it turns out it doesn't help us at all. So in this graph, I'm showing just the size of the brain, well, at least the cranial capacity, which relates to the size of the brain from various of our different ancestors, going through time. And remember, we're starting at about 2.5 or 3 million years when we start making stone tools. So notice, it doesn't go up, then we make stone tools. We make stone tools, then it goes up. And this is actually the current view, is it wasn't that we got smart enough to make stone tools by getting our brain bigger, and then that made stone tools because of that. The general view now is we started making stone tools, and that allowed us to grow big brains. Now this seems like a weird concept, but actually it makes a lot of sense, because in fact, having a big brain or being smart is a very, very stupid thing to do from an evolutionary point of view. And I'll point out why to you in a minute. But the argument goes that by using stone tools, we suddenly shifted from a diet that's very vegetarian-based, very herbivorous-based, to one that's very meat-based, probably by scavenging, not by hunting down animals, but by scavenging dead ones and breaking open their bones and so on. And that shift to that kind of diet increases the energy, the calories, and the qualities of nutrients that we're getting dramatically, and that allows us to afford to grow a big brain. So, and as I say, it's a very bad idea in general to have a big brain. And I can show you a few reasons why that might be the case. The first, at least for the mothers in this room, should be perfectly obvious. So you can see the problem, right? And in fact, outside the developed world, in, for example, hunter-gatherer societies that don't have access to modern medical care, childbirth accounts for around 30, on average, 30% of adult female mortality. So 30% of adult female deaths are in some way related to childbirth, which is just breathtaking. And it's true. I mean, of course, for anybody who's given birth, they will know, or been present at the birth of a child, they will know that it's approximately equivalent to being viciously beaten up by a gang of squaddies in a pub car park. It's not a pretty process at all. And you can see from this, it's just brutal. I mean, the damage it does and the demands it has on the body. And the main reason for this is because you can see what's happening. The brain, the head is just too big to come through, so it's going to cause all sorts of problems. Chimpanzee babies just plop out. There's not really much of a problem. Okay. The second problem with having a big brain is it's incredibly greedy for energy. Okay, so the brain constitutes around just over 2% of our body weight in an adult, and yet it accounts for more than 20% of our energy budget. And that doesn't change as well. So you might think, okay, yeah, but if I take it easier, I go asleep, or I sit at home and watch Jeremy Kyle or something like that, then my brain's not going to be using as much energy as if I was doing something else. No, it's using the same amount of energy no matter what. So it really is incredibly greedy. And having a greedy organ like a brain, you have to keep it going. There's no downtime. There's no, all right, I'm going to stop using it for a bit because I haven't got enough energy to use it. You stop using it, you die. So you have to keep it going. So it's a really expensive thing to carry around. Thirdly, from an evolutionary point of view, you want to get to reproduction early. Because if you don't, well, others are going to get to reproduction early, they're going to out-reproduce you, and their genes are going to spread in the population and yours aren't. So you don't want to have too much time between birth and starting reproduction. If you've got a big brain, it increases the time spent, the proportion of your life spent in development, so as an infant, as a juvenile, before reproduction. And that's actually a really bad idea from an evolutionary point of view. So those that breed faster are going to have an advantage. So having big brains just increases the amount of time before we reproduce, and that's a costly thing to do. Also, because our brains got big, it's kind of, it's had to go somewhere, so it's essentially blown up our skulls like a balloon, so that it's got bigger and bigger and thinner. So effectively, our brains are held in a cardboard box compared to most other animals. So if you take, for example, a similarly sized animal like a pig, and if you give it a stout whack on the head with a tire iron, it's not going to be very pleased with you, but it's not going to die. Whereas if I give anybody in here a stout whack on the head with a tire iron, they will probably die. So we've got a very risky place to keep our brain. That's also a very, very dodgy thing to do. And then clearly, like all complicated machines, the more complicated it gets, the more frequently there are problems with its function. And I mean, although of course I'm not suggesting that mental health problems are just down to brain size, but clearly there is a degree of a relationship there, and it does cost a great deal in terms of absenteeism, in terms of cost to the economy and cost to the health services and so on. Okay, so it's a bad idea to get smart, and there's no obvious correlation between brain size and how the clever things we do. In fact, the reality is that our brain sizes today are less than they were 50,000 years ago. So we've got smaller brains than people 50,000 years ago, and yet 50,000 years ago there were plenty of people that weren't doing anything clever at all. So can't be a brain size thing. So how do we explain this? So why did we get this appearance of modern human behaviour at different places at different times? Why isn't technological advance more closely related to increases in brain size? And well, if it's not, then why have big brains anyway? Because we know that it's such a stupid thing to do. Well, obviously lots of people have suggested lots of possible explanations for this. I mean, it's a common one that most people assume is that it's something biological. Some change in our biology, particularly in our brain biology, has made our brain not necessarily just bigger, but just work better at doing clever things, the kind of clever things that we can see in the archaeological record. Others could argue for culture. I mean, there are clearly things that are both cultural and biological. Language is obvious. I mean, you have to have a biological ability to language, but language is clearly cultural. I mean, it clearly evolves in a cultural way. Others have argued that, in fact, this change in behaviour, this more sophisticated behaviour, is actually a response to the fact that we've been evolving in a period over the last few million years called the Pleistocene. Now, this is a period, this basically means ice ages. And it's it's not in the ice age now, it stopped about 10,000 years ago. But for the previous about 2 million years, we're in these ice ages. And what that means is the climate goes up, down, up, down, up, down, up, down, really dramatically. So dramatically that it's very difficult to actually adapt to the environment you're in, because the environment just changes in the next year. So one argument is doing this clever behaviour as a way of dealing with living in very unpredictable environments. But I'm just going to suggest something else. I'm going to suggest that it's just to do with population size, so with demography. So, given that it is to do with demography, let's think about these behaviours not in terms of our biological abilities. Let's think about these behaviours in terms of our culture, okay? Because they are culturally inherited traits. So, we can think of culture as evolving in much the same way that we think of biology as evolving. Okay? There are a few slight differences in the rules, but the principles are basically the same. You have traits. They are passed on, they are variable, and there's differences in how often they're passed on or how often they survive. It's all you need for an evolving system. And culture is really important in humans. It is, you can have this conversation with many anthropologists. I don't care if they turn around and say the fundamental difference between humans and chimpanzees or other animals or other primates or whatever is opposing finger and thumb, or is upright posture, or is a big brain. It's just garbage. It's all rubbish. That's all rubbish. There is one answer to this question. Only one answer to the question of what is the most fundamental difference between us and other animals, and that's that we accumulate culture. Some animals have culture. Chimpanzees have it. Some crows have it. New Caledonian crows have it. Some porpoises, dolphins, and so on also have it, and probably many other animals have it as well. But they don't accumulate it. So they don't have more culture in any generation than could be obtained by a lifetime of just learning from others and learning by experimenting themselves. We have much, much more culture, more than could be accumulated just in a lifetime of individual and social learning. And that's the fundamental difference between us. In fact, it's such an important change. It is, if you think like a physicist, like a transition change. The rules of the game completely changed once you have culture. So culture changes the rules of evolution, fundamentally, and we're the only ones that are doing it. But because culture does evolve in a normal way, we can still quantify it, we can still measure it, we can still model it, we can still consider its processes over large periods of time. So cultural evolution, we can think of it as, for example, skills, techniques, abilities, ways of thinking, language constructs, conceptual constructs, anything that we can pass from individual to individual, from generation to generation, will follow the rules, the fundamental rules of cultural evolution. They're going to be copied across generations, they're going to have different survival, and they're going to behave in populations. That means that we can simulate it in a computer. So, we can ask, can this process, can these factors explain the emergence of modern human behaviour? So we simulated that. So here's a few simulations. Now, of course, simulations is not the final answer, right? Because it just shows that it could work, doesn't mean it did work. So what we had done on the left, in this left one, on the left-hand side of that, we've got populations at high density on one side and at low density on the other side. And we're simulating how culture will be transmitted from generation to generation. Basic, simple rules. Simple rules like when you teach somebody else or somebody learns from you, sometimes they do a worse job, sometimes they do a better job. The individuals try to choose individuals who seem better at things to learn from. I mean, you know, if you want to learn the piano, don't ask me, right? Ask somebody who can play the piano. It would be stupid to ask me. And everybody does this all the time. We generally go to the people we think are good at things, either because they've demonstrated it or because they seem to be good at other things, and so we generally assume, well, they must be good at that as well. So all of those processes can be modelled, and we've modelled it here. And as you'll see, the colour is representing the degree of cultural complexity in these different groups. And I've kind of interpolated just to give you a sort of an easier picture to see. And what you see here, if we go from the start, which will start in a second, so starting there, right? And now they're accumulating culture. And notice that on the left, where the population densities are higher, they're accumulating much more culture than on the right. Even though they're actually able to contact each other, people are migrating. In that simulation, people are migrating between all of these different locations. But even so, we build up more sophisticated, more rich culture on the high-density populations. On this one, they're at the same density, but the ones on the left just move more. So they move between groups more. They just exchange individuals and techniques and so on more. And again, you'll see this kind of white heat of technology. You know, this increase in technology is associated with the more mobile groups of people. So, okay, as I said, you know, it's a simulation, whoopee-doo. You know, all a simulation does is gives you a mechanism for something to work. It's a plausible way to explain this, but we now need the evidence, right? I mean, nobody's going to just accept that. You need actual empirical evidence that there is a relationship, which is predicted here, between population size or density and the amount of technology or sophistication of technologies in these populations. Well, we can do something here, because if I put my geneticist hat on, we can use genetic data looking at differences between individuals, actually contains information about the changes in population size through time. And so we can use that to estimate what population sizes were in different parts of the world through time over the last few 100,000 years. This is an analysis that was done using just that approach. And the amazing thing was, so first question is, you know, we see the biggest explosion in these technologies outside Africa about 50,000 years ago. Is there evidence for population growth outside Africa about 50,000 years ago? Oh yes, there definitely is. There's massive evidence for it, incredible evidence for it. So then we can ask the question, okay, let's just assume that we know when it started in Europe, it's about 45,000 years ago. Let's ask the genetics, how dense were populations 45,000 years ago? So we can then say, right, let's say that is the critical density that you require to get populations to behave in a modern way and be sophisticated. We can then go and ask the question, when did those populations reach that density in Africa? When did they reach it in the Middle East? Okay, there were some complications about doing it in other places, but at least in those places. So we did that. So when did it turn that in Africa? It turned it 100,000 years ago, which is when we see the appearance of modern human behaviour in Africa. When did it happen in the Middle East, in North Africa? It happened 40,000 years ago, which is exactly when we see the appearance of these technologies in the Middle East and North Africa. So there seems to be a really strong correlation between population density and cultural sophistication. So, just to summarise what that's saying, firstly it's telling us that cultural evolution is generally faster at helping us to adapt to the world than biological evolution. Well, we know that. So much so now that we are, I would say we're obligate culturals. So we cannot survive without culture. There are no Tarzans, there are no wolf children that run around without knowledge of anything being brought up by wolves and survive. It's just garbage. There's no evidence for it whatsoever. We are absolutely reliant on culture as a species to survive. Okay? It is our life support system, and we could never adapt fast enough just by changes in biology. So without culture, we would just be dead very, very quickly. And that's why physically as well, we're breathtakingly weak. I mean, even the sort of, you know, world's strongest man or whatever, you put him in a ring with a Neanderthal will rip him apart, because they're just much, much more robust. Their bones are more robust, they've got better joint attachments, better attachments of muscle and tendon and so on. So we are pathetic biologically because we are called culture. It's our life support system. The second point is that culture sophistication reflects human interaction rather than human intelligence. Now, that may not surprise some people at all, but it does also seem interesting, the idea that successful innovation depends less on how clever you are than how connected you are. Well, that may actually seem just as relevant today as it was 50 or 100,000 years ago. And it makes us think, well, okay, well, one of these particular features, perhaps the sexiest of all of these technologies that we see with modern human behaviour, is art. So maybe the key thing about art is the copying. Maybe it's not the creativity. Maybe it's the copying that's the key thing. And in fact, even our friend Mr. Picasso said this, said, good artists borrow and great artists steal. And he spent most of his early life simply copying, and that's why he became such a great artist. And as I said, it also throws up a few questions. So if we had the brains to behave in a modern way, long before we started doing so, then our brains could not have evolved for that purpose. That is absolutely clear. So if that's the case, why did we evolve big brains? Why did we get smart? Because for a long time we did nothing, at least in terms of technology, nothing smart with it. We usually think of art as expressing something within us, but there's no evidence of any expression of anything within us before populations were large enough to actually hold this copying of artistic skills. So maybe faithful copying is more important than creativity in art and culture. And finally, I guess you could ask, if population density and connectivity between people is getting greater, do you think that's making us smarter? I'm not sure that is the case, but it might be the case. Okay, so what I'll do is I'm going to stop there and I'll go on to a little bit about genes and the Bible. But before I go, do you have any particular questions about that first? Yes.
You say that there's a correlation between population density and creativity.
And many other things, but yeah.
My question is correlation causation?
Yeah, of course. So this is obviously a question that comes up quite a lot in science. The point is that we've provided a mechanism. We didn't discover the correlation. We looked at the mechanism of cultural transmission. That gave us a prediction that there would be a correlation. Then we went to check it. That correlation was never seen until we checked it, and then it was there. So that's more of a sort of scientific approach in that you make a prediction from your model, from your abstract representation of what's going on.
That doesn't discount
Absolutely
the possibility of correlation and causation.
Absolutely, absolutely.
Where do you take the step of it being, where's causation?
Absolutely. So that's a very good point, and one of the reasons it's a good point is, of course, imagine that you're developing new technologies. Well, wouldn't new technologies, to the extent that they're better, allow populations to grow more? So there may be a feedback loop. I have absolutely no doubt that there is that feedback.
So that's where your cultural, the meme idea.
Yeah, I don't like the word meme, but yeah, I know. Yeah,
you know what?
Yeah. So that's. I mean, I think that's true. I think there is a feedback. I think they can go. They can go both ways. So as you get more technological, population will increase. The argument, though, is why didn't it start before? Why did it start at a particular point? And it seems that the particular point it starts is the same population density in those different locations.
Doesn't quite answer the question.
So within. Okay, so ask it again. I'm trying to answer.
No, but where's the causation? So we've got a series of correlations.
Yeah,
as
right.
you spell it out, but underneath the correlation, what's the causation?
Oh, the causation is the nature of how population size affects the transmission of culturally inherited skills. So this is the point. We identified that process. Subsequent to it, a number of other studies have now tested it in small and large groups, also looking at populations in, for example, islands where you have large populations and small populations, a whole range of other scenarios, and found that there is a very strong correlation between the population size or interconnectivity and the actual amount of technologies that they have. Yeah, so there's independent empirical data, there is the model that shows how the mechanism works, there is the prediction, what the data should look like in the past, and then it looked like.
I suppose my question takes over a little bit from that question before, and one of the advantages of culture is that it can potentially be adaptive.
Fast.
If you've got the ability to exchange information and say there is all these things, and that would also be potentially a reason to find, therefore, higher population density. More people survive because more people.
Yeah. So I think that's just got to be true, and so I don't think we have to throw the baby out with the bathwater. In that we know that larger more technology can lead to larger populations, but that doesn't explain why you get more technology in the first place. But when we observe that we got this growth, then we seem to get more technology. Okay, that provides a plausible mechanism. The mechanism is there. Like all of science, it's still a hypothesis, but it seems to explain a lot more of what we see in the archaeological record than any other kind of explanation, like, for example, just a flick in the brain and getting smarter or something like that. It seems to explain well. I mean, fundamentally, you know, we're talking about these technologies appearing after many populations around the world had separated. So after, for example, populations in Europe and populations in Australia had separated from the common ancestral populations, then they got smart later. So the implication that it's some sort of biological change, well, that must have happened separately in those populations. Or the other implication is just horrible. You know, I mean, there's horribly racist implications, which I just do not believe for a second either. Because the reality is we just see these processes of cultural enrichment going on in different places, often when they're very, very distantly connected. And it does, again, always come down to, or it seems to always come down to, population density.
Can I just ask another question? You mentioned population as potentially a separate hypothesis to what I understood to be effectively dual inheritance theory. Which
this is dual inheritance.
So it's part of it.
Yeah, this is standard dual inheritance theory.
I thought one of the things you mentioned that was really fascinating is that there's this disappearance and reemergence of
in Africa,
in Africa.
Yeah.
I remember learning that through the migration out of Africa, maybe following several waves where there's immigration back and forth between Africa and the Middle East. I wonder if that migration could correspond to maybe changes in cultural density that changed over time, or the migration of cultural artifacts back and forth.
Yeah. No, I wish there was actually. I mean, you covered lots of different points there that people are working intensely on, but certainly population pressure has been indicated in movements out of Africa. However, I don't believe in pressure, because the first thing, pressure just means there's not enough resources for people to live. It's like, you know, if we were all living on potatoes grown in this room and we were all in here, I mean, you know, there wouldn't be enough potatoes grown in this room for us to survive. So you might think, well, that causes pressure. No, I think over large areas, pressure causes people to do the one thing they're exceptionally good at, which is just die. So I don't think it moves them out. I think they move out because there's places they can live, fundamentally. I think there is some relationship between the changes in population size and climate and then migrations out of Africa over the last 100,000 years. But the relationship between the technologies, that seems to hold a little bit as they move out, but doesn't seem to be very strong. As for evidence of multiple migrations out of Africa, it's breathtakingly thin. The data is, I mean, all the genetic data is just, it can be interpreted so many different ways. So it could be interpreted as indicating multiple or single ones.
To what extent do you think sexual selection and preference for intelligence, social intelligence, has also been a driver of this increasing?
Right. Yeah, probably. I actually think, so if it comes to that, the first question, I actually think it's social intelligence. I think that because social intelligence, firstly, it's the most computationally demanding problem we face in our lives. Because, I mean, firstly, we evolved in groups of about 100, 150 people, right? Dunbar number, exactly. But in that, so you have to, say you're in a group of 150 people, you have to socially coordinate, and it makes a massive difference to whether you survive or not, because you're not in a group, and you're not accepted in the group, you're gone. Which explains why social ostralization has such a profound effect on people today. But it's computationally massively problematic, because I don't just have to know what you think of me, I have to know what you think, I think, you think, I think. But not only that, but I have to know what you think, she thinks, I think, you think. And what he thinks, you think, she thinks, they think. And it's, you know, these are breathtakingly complex. Yeah, and the number of, exactly, so the number of sort of computations you have to do to work out coordinate even simple social tasks is so hard, and yet it makes so much sense to live in large groups because of predator avoidance. So there's always that pressure in primates to get bigger and bigger groups, and there's an amazing, for those of you who haven't seen this, you obviously know this, there's an amazing correlation, again, not necessarily causation, but there's an amazing correlation between the group size and brain size as a proportion of body size. And the argument is that you have to get smarter to live in big groups because big groups are more protective, you get less predation risk. But on the other hand, if you get to a big group and you're all a bit thick, well then the groups just fracture. And you can do this, you can do these experiments with macaques and things like that. You put them in larger and larger groups, the social system just breaks down, the whole lot of them just all fragment and go off in all different directions. So one argument is bigger groups for us requires more social intelligence, and that's where the real, and that's probably where we use most of our brains anyway, is social problems.
My follow-up question first was about sexual selection
So yeah, so clearly social intelligence is going to be sexually selected amongst other things.
Right. Yes. How much do you think is interbreeding between these
Neanderthals and Denisovans?
All these various other ones we now seem to say. In a sense, hybrid vigor is the...
No. No.
Well, it certainly is...
Male sterility. It generates male sterility.
No, but in terms of mating selection, you select for difference through pheromones, and that...
So
you breed out, but you breed you inbreed for cultural preservation.
Yeah, that's true. So that's actually the point about inbreeding for cultural preservation is really true. I mean, because culture is one of the few things that can evolve at a group level, whereas biology does not evolve at a group level. It's just garbage. Anybody who says it does, it's just rubbish. But with the interbreeding, we now know a lot more about this, and there's a paper coming out in a few weeks on this. But when humans and Neanderthals interbred, so we all got about 2 or 3% Neanderthal DNA in us. Unless you're African, then you haven't. But everybody outside Africa's got this. When they interbred, you can see the bits of the Neanderthal genome that got into us. So altogether, if you look at everybody around the world, you could actually recover 40% of a Neanderthal, because different of us have got different bits of Neanderthal. Right? So and it turns out that the one area where we particularly picked up from Neanderthals and we carried it with us today, that it wasn't got rid of, was exactly those areas that that affects, how you smell and how sexy you smell to people that are different from you and so on. Yeah, the MHC. Yeah, exactly right. So and this is this famous thing, smelly t-shirts that we you get blokes to wear get sweaty in these t-shirts and give them to women, and women will they will think, oh, that's disgusting, and it will usually be somebody who's very similar to them, and if they're different, they'll think, oh, it's quite nice. And we made this Horizon program once where we had this idea to test it, but extend it to chimpanzees. And so we got the chimpanzees to get all sweaty, and we got these women to smell them. They were like, it's quite nice. And it is a fundamental prediction of exactly what you're saying. So it does seem that happened with that and with Neanderthals, but the problem with mating with Neanderthals is it causes male sterility. And there's really strong evidence now that whole parts of the genome just didn't get through or didn't carry on from Neanderthals because they were causing male sterility in us. And in fact, it was so on the border that we'd been any more distant from Neanderthals, we probably wouldn't have been able to breed them.
Well, on the mating with Neanderthals, no, given that it is the Christmas shuffle, I feel we should do a little bit of biblical stuff. Just before.
Okay, let's move on.
So folks, we'll do a little bit of that.
Yep.
Like 5 minutes and then a few more questions?
Yeah, okay, I'll try and go through this quickly then. I've got some Bible stuff.
Get some Bible stuff in.
Okay, so I'm going to jump through some of the more sort of stuff that you should know anyway. So, okay, so as you know, we're all one species. We all share common ancestors. We're a relatively young species, so only about, the earliest fossil forms of us are only about 200,000 years old from Ethiopia. We are almost certainly an African species. We are not a particularly diverse species. Despite the fact that we think we look really different, well, we think we look really different, a chimpanzee probably thinks we look the same. We do have differences between our DNA. They're usually only about one of these chemical letters in every 1,000. So on average, if you pick 2 people, every 1,000 basically they'll have a slight difference. But those differences are small compared to things like, for example, gorillas. So we're good at noticing those physical differences between each other and between groups of people. And of course, that has a very, in some places, that has a very ugly history as well. But this often leads us to believe those differences are large. They're just not. So there's more difference between different gorilla groups in Rwanda forest than there is between any 2 individuals in the world. Genetic differences between individuals are much greater between 2 individuals than between population and, say, Africans and Europeans. So if I count the average number of differences between Africans and Europeans, well, it's almost 10 times as many differences between me and another European. So there's much more difference between individuals than between populations. Most of those differences have absolutely no effect on us. And most of what does affect our biology doesn't make any difference to how we look either. So the differences that we see are the tip of the tip of the tip of the iceberg of genetic differences, and there are not many genetic differences compared to most other animals. So even though genes determine most of our biological characteristics, genetic differences between people are almost entirely a reflection of where they share common ancestry. And this is an important point. But because we've got a lot of DNA, I mean a lot of DNA and a lot of genes, then there will always be some differences to look at and play with. So I can give you an example. So here are a bunch of people, and here are another bunch of people. So these people, we've got a Fulani woman here, we've got an Irishman there, we've got a Bedouin woman there, we've got some Swedes, we've got a Bayesian man here and somebody from the Indian subcontinent. They all have something in common to the exclusion of them. Okay, so various people from East Asia, from Australia and various other places, including apparently Chuck Darwin. And that fundamental difference is that they can digest the sugar in milk as adults, whereas they can't. Okay? So there are many differences that do not, those genetic differences that don't necessarily correlate with where in the world you're from. In fact, most of them don't correlate very well with where in the world you're from. So we can see that, that's the distribution of that trait, the ability to digest the sugar in milk as an adult. It's a genetically determined trait. I would imagine most people in this room are okay with digesting milk, but some won't be. So genes do tell us a lot about our ancestry, and the differences between genes in different individuals is clearly a reflection of when they share, or when they share common ancestors and the common ancestors they inherited those genes from. Okay. So we will all have common ancestors. Different parts of our DNA will come from different common ancestors at different points in the past, because we can have many, many common ancestors. So one easy way of looking at these things is just to look at the simple systems, the simple genetic systems. And there are 2 in particular that are widely used. They're a little bit overused in my opinion, but they've been widely used in looking at population histories and relationships. So one of them is this baby here. This is the Y chromosome, right? So this is from a bloke because there's a Y chromosome. Y chromosomes make men male, so obviously they're transmitted father to son. Women haven't got Y chromosomes, so you can obviously men don't get their Y chromosomes from their mothers. And then there's also a piece of DNA in our cells called the mitochondrial DNA, which we only get from our mothers. So men have got it, but men are a dead end. They're not going to pass it on to their children. So that goes through the female line. So we can use those to trace ancestry through the male and female line. And we can compare them. And so if I compare my mitochondria with Dan's mitochondria, we would work out how different they are, and the difference will be a reflection of how long ago his mother's 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 mother and my mother were the same woman. Is your mother's mother's mother? So can we say anything about recent common ancestors through the male and the female line. And does that tell us anything about, for example, the first man and the first woman? So, which in the Bible, of course, is Adam and Eve. Well, we have to think again. So let's think just simply in terms of a population of, let's say, women. Okay, so this is generations of women. They're non-overlapping through time. So we've just got today's women. Each of those women has got mitochondrial DNA. She will have got it from her mother in the previous generation. But obviously in the previous generation, some women didn't have any daughters, and some women had more than one daughter. So the number of women in the previous generation whose mitochondrial DNA made it through to today is going to be less than the number of women in today's generation. And that inevitably is going to go down and down and down as you go back through the generations. Well, it might stay the same, but it's one thing's absolutely for sure, it's impossible to go up because no woman can have more than one biological mother. So inevitably it's like a ratchet. It's just going to go down and down and down till it gets to one single female line common ancestor. So that doesn't necessarily mean that there was nobody else around at the time, and they may have had daughters, but they simply didn't have daughters who had daughters who had daughters who made it all the way through to today. Now that's going to be true through the female line, and it's going to be true through the male line. But it is a random process, and so that's just one roll of the evolutionary dice. You can roll it again and you might get something different purely by chance. Also, there's something else, which is that some males are far more highly sexed than they should be. So here's an example. Basically the principle is there's greater variation in the number of offspring men have compared to women. Most women will have some offspring, whereas at least in the past you often got a lot of males that had no offspring and then one or two males that had a lot of offspring. So a classic example of that is this chap here, Moulay Ishmael the bloodthirsty, although why he was bloodthirsty given his prodigious reproductive output, I can't imagine. They stopped recording the number of children he had at 700 sons and at about 342 daughters, but they only stopped counting because they couldn't be bothered anymore. Some people have suggested that he had more than 3,000 or 4,000 children. Now compare that to the number of children a woman can have. So her name is not recorded, but apparently the wife of Fyodor Vasiliev, who was a Russian peasant in the 19th century, allegedly had 69 children through 27 pregnancies. Now that's just breathtakingly large number of children, but clearly it is absolutely nowhere near the number of children that a man can have. So what does that do? I mean, we don't care about these things. All we care about, of course, is DNA trees. So what does that do to our DNA tree? Well, what it does is you've got a lot of blokes in the previous generation having no children, and, or in this case, sons, and a small number of males having a lot of sons. In this case, we're just considering sons, let's say. And what effect does that have? Well, it pushes back or brings forward the ancestry data of the tree. So therefore, if we follow these rules, we would expect that the common ancestor through the male line and the common ancestor through the female line would have lived at different times, and we would expect the male line ancestor to have lived more recently. So now remember, we can actually look at real DNA and we can estimate that, and we can get reasonably good estimates. So common female line ancestor, she lived about 190,000 years ago, and she was African. And it's very clear that she was African because the way that her descendants branch off. Fine, we're an African species, that's fine. 190,000 years ago, fine. I mean, you know, that turns out that actually we find the earliest human fossils about 196,000 years ago. Not that I think they're connected, but anyway. So what about the Y chromosome, common male line ancestor? Actually 340,000 years, so he's much older. So clearly, first off, Adam never met Eve. And if you want to call her Eve and him Adam, then they clearly never met. In fact, they lived at very different times. But also it seems that this Adam, this Y chromosome Adam, lived longer ago than this mitochondrial Eve. We only just discovered that very recently. We used to think it was much more recent, but it's not, it turns out. So that shouldn't come as too much of a surprise to you, that Adam never met Eve. I hope that the way I showed you how they're inherited shows that you would expect that difference anyway. But then ask this question. This might come as a bit more of a surprise to you. So when did the common ancestor of everybody alive today live? When did the most recent person, when was the most recent person alive who's actually the common ancestor of everybody alive in the world today? So we want to take a guess.
1400s?
1400s?
Genghis Khan? Was that first one?
Genghis Khan certainly got around. He certainly spread his genes far and wide, but not quite, no. But remember we're dealing with like 100, 200,000 years, 300,000 years here.
90,000?
90,000, okay. You got any advances on 90? No? Okay, well the actual date is about 2,500 years ago. Not only that, but that person who was alive, it's a real person, it's not an abstraction, it's not some crazy scientific nonsense created in a computer. You may not have inherited any genes from that ancestor. And the reason for that is that as you look back through time, you will almost double your number of ancestors, right? 2 parents, 4 grandparents. Not quite double, because we're all slightly inbred. So, sometimes your mother's father's father's mother's mother's father's father's mother is also your father's father's mother's father's 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 mother, or something like that, right? So we're all slightly inbred. But if you go back in time, doubling it, you can see that you're going to get a very big number of ancestors very quickly. And yet your bits of DNA come in chunks. And those chunks don't tend to get broken up very much. So once you've got more ancestors than you've got chunks of DNA, so then you must have ancestors from which you've inherited no chunks of DNA. And it's so recent because we're all spread in our ancestry net as we look back through time so wide, so fast, that we all start meeting up really, really, really quickly. And about 4,000 years ago, everybody who was alive was either the common ancestor of everybody alive today or of nobody alive today. So when you watch one of those programs like Meet the Ancestors and they've got some archaeological site or something like that, and say, are we descended from them? The usual answer should be, if they had children and those children had children, then yes, you are descended of. I don't care whether they were dug up in China, whether they were dug up in India, whether they were dug up in North America, whether they were dug up in Africa, doesn't matter. You are still a descendant from that person, almost certainly. So if you were attempted to write off to one of these DNA genetic astrology companies that purports to tell you where your ancestors come from, well, let me tell you where ancestors come from now. They come from everywhere. So do you want to know if you've got Viking ancestors? You have. Anglo-Saxon ancestors? You have. Saracen ancestors? You have. Jewish ancestors? You have. We've all got ancestry from all over the place. So these companies that will do some DNA test and tell you that you're a Celtic princess or a Viking warlord or something crap like that, it's just rubbish. It's really rubbish. Okay, I'm just going to finish with a couple of biblical examples now, or another biblical example now. And this is the Jewish priesthood. So the Jewish priesthood were the original priests in the temple in Jerusalem. There is no temple, it was destroyed. It was destroyed twice, but last time it was destroyed by the Romans, and so there's actually no, strictly speaking, no priests. But the status of Jewish priest is maintained across generations, and it's patrilineal. To be a priest, your father's got to be a priest. They're often called Kohanim, and they often have similar names like Cohen, Con, Katz, or something like that. Although Leonard Nimoy was also a Kohanim. You see him doing this sign, I'm not a Trekkie, but for those who watch Star Trek, he does this sign. That's the sign of the Kohanim. It's actually the sign of the priesthood. You can see it. In a second. So, according to the Bible, Moses comes across the Red Sea, he goes up onto Mount Sinai and gets the 10 Commandments. So, what am I going to do? God says, go to the Promised Land, and they go there and they build the temple. And God also says, right, your brother's descendants, Aaron, played by Anthony Quinn in the film 10 Commandments, they will be the priests in the temple. and their male line descendants all the way through. So they did that, allegedly, and then they built the temple. Then the temple got knocked down about the 5th century BC by the Babylonians, so they went to Babylon and they wrote by the rivers of Babylon and all that sort of stuff. And then they came back, and then they built the second temple. Then they got on the nerves of the Romans. The Romans destroyed the second temple, so they formed a diaspora. But they've kept alive this tradition that if your father was a Kohanim, a priest, then you're a Kohanim. And about 2 to 4% of the Jews living today are Kohanim. And they still have certain rules about how they have to behave. Not allowed to be in the same room as a dead person. If their wife is raped, they have to divorce her, amazingly. And if a Kohanim is present, he should carry out first reading of Torah scrolls worship, and various other rules as well. So if you go into a hospital in Israel, you've got the corridors have got these sort of double locked doors, so only one is open at a time, just in case somebody dies and the Kohanim is walking across down the corridor, so he's not in the same room as a dead person. So they're actually saying that remember that they share a commonality through the male line, and therefore they should have basically the same Y chromosomes. Because remember, Y chromosomes only found in genetically male individuals. It's a very, very small chromosome. It contains very few genes. Many of you would argue that it contains absolutely no useful genes whatsoever. There are differences between different Y chromosomes, between me and Dan's Y chromosome, for example. Only inherited through a male line, so those differences are simply a reflection of how long ago, let's say, me and Dan share a common male line ancestor. Sorry to bring your father into it.
That's not even
So we took a whole bunch of Kohanim Y chromosomes and non-Kohanim Jewish Y chromosomes, both from Ashkenazic and Sephardic Jews, and had a look at those chromosomes. Now, the non-Kohanim Jews had a whole range of different Y chromosomes, just the same as any other population anywhere else in the world. But the Kohanim, most of their Y chromosomes were of one type. And most of the rest that weren't of that one type were of a type that was only one mutation different. Okay? Now remember, mutations make the differences. So we've got our common type, and then there's just a bunch of them that are slightly different. Now, we can therefore assume that at some point in the past they all had this common type, and that the differences are just due to mutations since that time of common ancestry. And because we know how fast those mutations happen, we can estimate how long ago that common ancestor of all these Kohens lived. Okay? So we estimated it for both Ashkenazic Kohanim or priests and for Sephardic Kohanim or priests, and then we estimated it for all of them, and we got this date, which fits rather remarkably well with when we think Exodus may have occurred. So we've got a date from people living today, from the genes of living people today, who make a claim of biblical origin, and it fits with the date of their biblical origin. And remarkably, down in South Africa, there are this group of people called the Lemba. Really cool. They're black. They look like normal black South Africans. They speak Bantu languages and so on. They have many different religions, including Islam, Christianity, and so on. But they have this origin myth that they originated in a place called Judea or Senna, and that they migrated down there. So they claim Jewish origin, and they used to be called the Black Jews of Southern Africa. And we don't know where this origin myth comes from, but they do practice circumcision, but that could be Muslim or African. They also have food taboo, so they wouldn't eat a hippopotamus or a pig or any pig-like animal, and they whole range of practices that would be typically Jewish. So we looked at their Y chromosomes, and about 2/3 were typically Jewish, or at least Semitic, shall we say. But then they're also formed into clans, 12 clans, like the 12 tribes. And the most senior, the Behaviour clan, not only did they have the highest proportion of typically Jewish Y chromosomes, but in fact virtually all of them were exactly the same as the ones in the priests in Europe and all over the Jewish world in the company. And in fact they've been romanticised. I think somebody's made some film about them now. Look at this. though they don't look very South African to me. They've also had various proselytizing rabbis going down there and trying to convert them to normal worship and so on. And then people saying, well, they're going to come to Israel, but they don't care because they're quite skilled and quite rich and they don't have these problems. But anyway, they now see this as evidence that they have that Jewish origin. Okay, I will stop there. Sorry for going over time, but thank you.